Good evening, everyone. I am Jiniko. My mention number is 193436, and this is my partner, So Wei Xiang. His mention number is 193200. We will going to present the topic of chemical process and material today. By definition, chemical process is defined as an process determined by the atomic and molecular systems and molecular composition and structure of the substance involved. There are many structures produced by the chemical process. And now for today, I am going to present about the chemical process of the methanol. First of all, what is methanol? Actually, methanol is widely used in our daily life, such as the plastic bottle made of methanol and other chemical substances. The perfume also made of methanol too. Other than plastic bottle, the shampoo also has the material of methanol. So, how to produce the methanol, and there are how many steps to produce the methanol, and what is the purpose of each step? We should think about it before we know about the process of methanol. Basically, there are 5 steps to produce methanol. The first step is desulfurization. Second one is still reforming and the methanol synthesis and mist separator, and the last is the methanol distillation. Okay, now for the desulfurization. It is used to separate the hydrogen sulfide from the natural gas to produce the purified natural gas under the condition of temperature 395 degrees Celsius and pressure of 35 atm with the N-methyl-2-pyridine as a solvent to absorb the hydrogen sulfide from the natural gas and produce the natural gas in this process. The next process is steam reforming. It is one of the methods to produce hydrogen and carbon monoxide from purified natural gas. Actually, the steam reformer is widely used in industry. This stage is heating up to high temperature of 700 degrees Celsius and pressure of 25 atm. Next, in the methanol synthesis, a conversion of synthesis gas to raw methanol took place in this process. This reaction is under temperature of 260 degrees Celsius and 30 atm with the carbon dioxide as metal catalyst. The catalyst can speed up the reaction and it will remain at the end of the reaction. Then, mist separator is the process of phase separation of the liquid and the gas that usually occur in the pressure vessel. There was a cooler in the middle of the mist separator to decrease the temperature of the product from the methanol synthesis to 37 degrees Celsius, and the pressure is 60 atm. Okay. Lastly, in methanol distillation, the obtained methanol solution from the mist separator is purified in this distillation column. to yield higher purity of product under temperature of 40 degrees Celsius and pressure of 35 atm. After explaining all the purpose of the process of methanol, then I will pass the presentation to my partner, Wei Xiang.
Okay. Good evening, everyone. I'm Wei Xiang. Since my partner Jeannie already presented the process of methanol, so now I'm going to talk about the gases present in the methanol process. There are several gases such as methane, ethane, carbon monoxide, hydrogen, nitrogen, and water involved in the process of methanol. What will happen if all these gases react with each other in the process of methanol? Actually, for the first step, which is desulfurization process, hydrogen sulfide will completely removed by weight and achieve higher efficiency. For the steam reforming, there are three reactions take place in this process to produce hydrogen and other gases. Why we need to produce hydrogen here? This is because hydrogen is the basic material in the process of methanol. The first reaction is when methane reacts with water to produce carbon monoxide and hydrogen. The following reaction is when carbon monoxide reacts with water to produce carbon dioxide and hydrogen. The last reaction is between the ethane and water to produce carbon monoxide and hydrogen. The hydrogen produced by these three reactions will be used during the next steps. Okay, in order to yield higher product, there are four ways should be considered in the process, which are the feed ratio of water to methane is 4, and the product ratio of hydrogen to carbon monoxide is also 4. Then the product ratio of carbon monoxide to carbon dioxide is 2.86, and the fractional conversion of methane is 90%, which means that 90% of methane can react with carbon monoxide to produce higher product of hydrogen. Next, two reactions are involved in the methanol synthesis. The reaction is between the carbon monoxide and hydrogen to produce. The reaction is between the carbon monoxide and hydrogen to produce methanol, and carbon dioxide reacts with hydrogen to produce methanol and water. Alright, here is the reaction that produce our product, methanol. In this process, nitrogen gas acts as inlet gases, which is the input mole flow rate is equal to output flow rate. The feed ratio of water to carbon monoxide is 2:1, and the conversion of carbon dioxide is 55% to get high selectivity of methanol. For the mist separator, it is non-reactive reactor, which means that there is no reaction occur and liquid and gases are 100% separately in this process. The gas will be discarded and the liquid of impurified methanol and water will enter the next process, which is methanol distillation. For the methanol distillation, it is also a non-reactive reactor, which distillate the impurified methanol from the mist separator to produce purified methanol. The water and the impurified methanol will come out as a bottom product, and the water and purified methanol will come out as the main product. So the methanol will be produced at the end of process. Alright, we have now come to the end of our video. However, we like to quickly summarize the main points of the topic: chemical process and material. There are 5 steps to produce the methanol, and there are a lot of reactions between the gases in the process of methanol. Okay, that's all we have today. Thanks everyone.
Thank you.